Hello everyone, welcome to lesson 8-7, solve one-step inequalities. This lesson is found on page 635. As we mentioned before, inequalities work very similar to equations, except now we're saying that one side is greater than the other side, or greater or equal to, or less than or equal to. They're not the same value, but the process, the computation, are very similar. Let's look at a real-world link, baseball. The graph shows the number of home runs that the top hitters on the baseball team hit last season. So we have Josh. Looks like he hit about 12. Mark hit about 23. Nate exactly 15. And James 19 or 20. Okay, we see that there. Write an inequality that compares the number of home runs Nate hit to the number of home runs Josh hit. So we have Josh, okay, right here, right there, and we have Nate, so Josh and Nate, Okay, which is greater than which? Let's see. I know that this symbol right here is telling us that the number on this side is greater than the number on this side. So we have Josh and Nate. Nate is going to be on this side. Nate looks like he has exactly 15. So Nate had 15, which is greater than 12, which is Josh. Okay, so Nate and Josh. Be sure to write down their names under it too. This will tell me that you watched the video and you got this information from the video. Number 2. Write an inequality that compares the number of home runs James hit to the number of home runs Mark hit. So now we have James and Mark, right? So we have James right there and Mark. Clearly Mark hit more, and we estimated that Mark hit 23. So Mark is going to be on the greater side. Mark hit 23, while James looks like only hit 19. It's not quite at 20. 19. Okay? Suppose James and Mark, okay, so we have James and Mark. Let's make note of that. James and Mark each hit 3 more home runs. Write a new inequality that compares the number of home runs James and Mark hit. So they each hit another 3. Okay? So we know that on this side I have Mark. Mark hit another 3, so he would have hit 26. So Mark over here hit 26. Right? And James over here, he hit 19, but if another 3 would make him 22. And there we go. Okay? We changed one side, we added 3 to one side, we added 3 to the other side, and the inequality remains true. This side is still greater than this side, or 22 is still less than 26. So as I mentioned before, we're going to use the same skills, the same procedure that we did to solve equations, and we're going to solve inequalities this time. So use addition and subtraction properties to solve inequalities. Okay, here we have, for example, and this is how it works. If I add 4 to one side of the inequality, I have to add 4 to the other side to maintain it true. So it's 9 is still less than 13. And the same goes for subtracting. If I subtract 3 to the 6, I have to subtract 3 from the 11 so that it remains true. So here we have an inequality. X plus 7 is greater than or equal to 10. So what is x? Well, in order to solve x, we have to, here is addition, so we're going to use a subtraction property of inequality, and with whatever you subtract from one side, you must subtract from the other side, so that x has to be greater or equal to 3. If this is 3, it's going to equal 10. 3 plus 7 is 10. It's equal to 10. Okay, so it has to be 3 or more. 3 or more. Okay, so x can be more than 3 or equal to 3. You see that? And how do we graph that? Well, we're saying that x can be more than 3. Don't forget, look here. We're saying that x can be more than 3. So it can be anything in this direction, any of those numbers, more than 3. But it can also be equal to 3. You see that equal sign underneath right there? That's the equal sign. So we color in the dot. We color it in to say that it can also be 3. If we didn't color it in, we would say that it cannot be 3, it can only be greater than 3. Here we have another inequality. We have x minus 3 is less than 9. So what can x be? Well, let's work it out where we isolate the x by adding 3. Okay, and you see it right there. We're adding the 3. Okay? And we add the 3 to the other side. So x has to be less than 12. X is less than 12, not equal to, just less than 12. So here we have our 12, and we're saying that x can be anything in this direction, 11, 10, anything in 11.5, 11.3, anything in there. But it cannot be 12. You notice how 12 is not colored in? You see that? Because it's not 12. It's anything less than 12. X is less than 12. Let's go ahead and solve these two inequalities. We solve them the same way we would solve the equation. So look at A. Okay, for A, we're going to subtract 2, use the subtraction property of inequality, and subtract 2. That leaves me on this side with the 3 and my n. This is gone, right? So n is less than or equal to 3. It can be 3, but it also has to be less than. So when I draw it, I know that it can be 3. So I'm going to go ahead and just circle that in aggressively. Circle it in, and I'm saying that n can be 3 or less. Alright, let's try y. To isolate the y, I have to get rid of this negative 3, so I add 3. I use the addition property of inequality. And I add 3 to this side as well. This side becomes 12. And this is gone, and now I have my y. My y has to be greater than 12 for this statement to be true. It is. If this is greater than 12, for example, 13, minus 3, this side would be 10, and 10 is greater than 9, so that is true. Okay, so how do we graph that? We would graph it by saying 12. Notice I didn't color it in, okay, because it's saying that it's not equal to. Okay, notice it is saying that it's greater than. So this y is greater than 12. Greater than 12 will be in this direction. You see? Just the same way we use addition and subtraction property of inequality, we can do the same with multiplication and division. So when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. Now remember, they're saying positive number, and this comes into play later, because if it's a negative number, it's going to change the direction of the inequality. But we'll get to that a little later. Quickly, as you can see here, if we multiply one side by 2, you have to multiply the other side by 2, so the inequality remains true. Okay, as you can see. And if you divide by 2 on this side, it becomes 8. You have to divide by 2 on this side, so it becomes 6, and the inequality is still true. 8 is greater than 6, just like 16 is greater than 12. And if x is less than 9, notice that we color on the side that is less than 9, but it's also equal to 9, so we color it in. Okay, and that's how you graph it. And for number 4, we have division. X divided by a is going to be greater than 3. Okay, so then we have to do the opposite operation, which is multiply. We multiply, and the 8 is gone on this side, and we multiply on that side, and we get 24. Okay, so x is greater than 24, but not equal to. So here's 24, so we color everything that's greater than 24, and we do not color in the circle because it's not 24. Okay, let's try this next example. We have multiplication here between the coefficient and the variable, so we have to divide, which is the opposite operation. That gets divided out, this gets divided out, and now all I have is my x left is less than 8. So I have 8, and it's less than 8. I don't color it in because it's not equal to 8, it's just less than 8. Okay. Over here I have multiplication, so I'm going to multiply both sides by 6, multiply by 6, this is gone. I have x is greater than or equal to 7 times 6 is 42. Okay, so x is greater than 42. So I'm going to put my 42 there, but remember, look at that, it's also equal to it, so I can color it in. I'm going to go right ahead and color it in and say that x is greater. X is everything greater. For the word problem, Laverne is making bags of party favors, okay, for each of 7 friends attending her birthday party. She does not want to spend more than $42. So $42 is the minimum amount, the maximum amount she can spend. So what I'm thinking here, I don't know if you've seen it already, but her cost has to be less than $42. Okay, her cost. Write and solve an inequality to find the maximum cost for each party favor. So this is the cost of each party favor, and she wants 7 for 7 friends. So it's 7 party favors has to be less than 42. See, does that make sense? 7 party favors has to be less than 42. Okay, so then we write it out. Oh, sorry, less than or equal to, because she can spend up to $42, but no more. So it could be equal to $42. We solve for it, and the cost has to be less or equal to $6 each. Makes sense, because 7 times 6 is 42, and that's the maximum she can spend. Okay, please leave the guided practice for class so we can do it together. But complete the entire independent practice. As you can see right there, it's exactly what we've been doing in the video. If you're not sure on how to do it, please go back to the video and see the examples in the book. Just to be nice, let's do the ones in the back of the book on the next page. So let's start with this one over here. Okay, we have fractions, and we're subtracting, so we have to add. So to this side, I'm going to go ahead and add 7/12, right? So that's gone. And to this side, I'm also going to add 7/12 to keep with my property of inequalities. On this side, I have P left. Sorry, I'll write it down here, guys, because it's starting to get a little crowded up there. P is greater than 3 plus 10, 3 over 10 plus 7 over 12. Okay, what is my common denominator between these two numbers? I know that 60 is the next number that I will get with my 12 if I count by multiples of 12. So I'm going to go ahead and just write 60. Okay, what did I do to the 10? I multiplied it by 6, so I must multiply the 3 by 6 and I get 18. Plus, what did I do to the 12? I multiplied it by 5, so I multiply the 7 by 5 and I get 35. Right? And 18 plus 35, I get 40, 45 plus 3, 53 over 60. Okay? So how can we graph this? Well, we have to actually now write it in fractions. So I'm just going to go right ahead. I know that one of them is 53 over 60. My next one will be 54 over 60. And 55 over 60, and so on. Okay, and we're saying that P is greater than 53 over 60, right? That's what we solved over here. You see it right there, right? Okay, so I leave it empty, and I'm saying that P is greater. Okay, P is greater. And number 8, we have addition, so let's subtract 0.3 from both sides. 0.3, subtract. And the 0.3 will be gone from this side, and from this side when I subtract, I get 1.4. Okay, so F is less than 1.4. So I go ahead and I write 1.4, 1.5, 1.6, 1.1, 1.2 or so on. F is less. So here's my 1.4. I don't fill it in because it's not equal to, and I just color it to the side that it is. Alright, that's all for today, boys and girls. This is the key answer. I'll see you in class.